Hi guys, welcome to another episode of Must Know Definitions for WAEC. Here we define chemistry terms that are usually asked in WAEC and JAMB exams. Students were asked to define isotopy in a theory WAEC question in 2021, and a lot of candidates actually defined allotropy instead. So much that the examiners made a comment that a lot of candidates defined allotropy instead of isotopy. Not on my watch. Let's fix that today. So today we're learning the difference between isotopy and allotropy. Let's get right into it. We'll start with isotopy. Elements that exhibit isotopy, we call the examples isotopes. So isotopy is a phenomenon where atoms of the same element, okay, atoms of the same element have the same atomic number but different mass number, and the difference in mass number is due to the number of neutrons. So isotopes of the same element will have the same atomic number, but they will have different mass number. So let's take, there are so many examples of elements that exhibit isotopy. A common one that's usually asked in WAEC is chlorine. So the isotopes of chlorine are chlorine 35 and chlorine 37. So that's the mass number. So here I've written chlorine 35. The atomic number is 17 and the mass number is 35. For chlorine 37, the atomic number is 17 as well, and the mass number is 35. Again, they have the same atomic number. So if you walk through this example, what will be the number of protons in chlorine 35 and chlorine 37? You know that atomic number is the same thing as the number of protons, right? So here, the number of protons will be 17 for chlorine 35, and for chlorine 37, it's going to be 17 as well because they have the same atomic number. What will be the number of electrons for these isotopes of chlorine? We are dealing with a neutral, we are dealing with neutral atoms here. So the number of proton is equal to the number of electrons because these isotopes are neutral. So number of electrons is still going to be what? 17, because the number of proton is equal to the number of electrons. Beautiful. Now, how many neutrons does each of these isotopes have? Let's find out. So to find the number for chlorine 37, the number of protons here is the same because they have the same atomic number anyway. So it's 17 for both. The number of electrons, because these isotopes are neutral, is going to be equal to the number of protons. Again, 17 the same. Now to the number of neutrons, that's where we have the difference. So we can see this is where the difference exists. So we can say these are isotopes of chlorine. Other elements that exhibit isotopy include hydrogen. So there are 3 isotopes of hydrogen. So you have protium, deuterium, and tritium. So they have mass number 1, 2, 3, but they have the same atomic number of 1. Same goes for carbon. There's carbon 13, there's carbon 14, and there's carbon 12. Three different isotopes. Same goes for fluorine and oxygen. All these elements exhibit isotopy. Isotopes of the same element, they will have the same chemical properties. So isotopes of the same element will behave the same way because they have the same chemical properties. However, they will have slightly different physical properties. So for isotopes, they have the same chemical properties but slightly different physical properties. I hope you find this helpful. Please like, follow, and share, and subscribe. You can check out the playlist on the other definitions. If you like me to define any term, leave it in the comment section and I will do that next time. Thank you.